It square roots and cube roots, which is quite different, whether something is getting squared or something is getting cubed. No, put it back. Whose is it? Give it back to Devin. You're too late on that. Class has started. All right, so I did, because these are all square roots, we don't see a little 3 here. We don't see a little 3 here. I did put a list of all square roots on the board. So, any number that you have to square root that is in between these will come out a decimal. So for that reason, these are actually called perfect squares because they square root to be integers. Okay, so when it says simplify, really a lot of times the directions will be even more descriptive. It'll say write in simplest radical form. Because if it doesn't say that, a lot of students will write it in decimal form. Close. There is, the problem with 40 is 8 times 5. So I like 8 and 5 as a suggestion. However, like 8 doesn't square root and neither does 5. It's a decimal. And I only want things that square root to be integer. So yes, I'm thinking more along the lines of 4 times 10 because 4 does square root. So for all of these that I'm rewriting, I want to have one of these numbers in the radicand. So I'm going to rewrite 40 as 4 times 10. Now, 8 and 5 does make 40, but 8 and 5 doesn't help me simplify the radical. So 4 and 10 is a little better. The property of radicals say that I can actually separate this. So it's the square root of 4 times the square root of 10. Yes, it is. It looks so innocent, but it's kind of a long process. And then the square root of 4 is 2. So the answer ends up being 2 times the square root of 10. And once you get into Algebra 2, the calculator does it for you. But for your Algebra 1 curriculum, they don't let you use a calculator that'll do this for you. You have to do it by hand yourself. Just to show your understanding of perfect squares. Number 2, the square root of 30. So does 30 divide by 16? No. Does it divide by 9? No. 4? No. 30 is a trick. Simplest radical form already. Right. And then you square root 1. But then it's 1 times the square root of 30 is still the same. There's no change. All right, and so this is going back to last Wednesday. Right, so it's been a while, but we did cover adding and subtracting like radicals. Now, these cannot be subtracted because it has to be like terms. Like it has to be like 4x and 18x, or 4 square root of 2, 18 square root of 2. It has to be the same square root. So we can't subtract until you have like radicals. You can't add or subtract until radicals match. So 4 square root of 2 is as simple as it can get, but this 18 can be rewritten. Nolan, did you do 18 yet? David, can you see the list where you're at? Man, I wish I could translate it 1 foot horizontally. Does 18 divide by any number in here?
Yeah.
So 18 does divide by 9. So I'm gonna rewrite the 18. I'm not gonna forget about the 4 square root 2, but I am gonna kind of leave it to the side and focus on this 18. I'm gonna rewrite 18 as 9 times 2. And that's equivalent. 18 is 9 times 2. And then I know we can separate those. The product property of radicals. So the square root of 9 times 2 is literally the square root of 9 times the square root of 2. And now I know the square root of 9 is 3. So that's 4 square root 2 minus 3 square root 2. Because you actually square root it. Do you understand that, David? Yeah. And now we've created radicals that match. So it says you can't subtract until radicals match. Well, the radicand here is 2 and the radicand here is 2. So now we can do it like terms. So it's just like if this was 4x minus 3x would be 1x. 4 square root 2 minus 3 square root 2 is 1 square root 2. And we don't typically write the 1. So this answer is just the square root of 2. Yeah. All that work for that answer. Yeah. I'd like to see you, James, try 4. Your paper, and then I can call on you. Yeah, so I went 1, 2, 3, and this kind of went, and now I'm doing 4 and 5. So you can pick any one of these 3, James. Any one of these 3 you can rewrite.
Okay, I'll do this 25.
Okay.
It's 5.
It's 5. Square root of 25 is 5. So just go ahead and rewrite it. Good. We're already a little bit more simplified. 72 is pretty big. So there's 2 ways to do a number like 36, okay?
36.
Oh, I just gave an answer. A number like 72. 9 works, but if you do 9, you're going to have to do it again. Should I show both methods, or do you want me to show you just the shortest method to not keep it? Shortest method. Okay. So 72 divides by 36. Now, in order for you to access the shortest method, in order to know that, you have to know that 72 divides by 36. That's not one that we often think about really easily, but actually the more you practice this section, the more you will, because 72 kind of comes up a lot. So we're going to rewrite 72 as 36 times 2. And Nolan, I'll just show you what happens if you do it 8 times 9. I'll show you right now, okay? So if you do 9 times 8 is 72, that would be 3 square root 8, right? Now 8 is the same as 4 times 2. So now I would have to do 4 times 2. Because you just would have to do it again. And the square root of 4 is 2. So then you end up at 6 square root 2. That's it. Now on this method, the square root of 36 we can do. It's in our square root list. The square root of 36 is 6. Don't do that. So now we're at 5 plus 6 square root 2 minus 8.
That's it.
No, we can keep going.
That's too much. Wait, the square root. They took it away. Yes. Why?
It's still there. Sorry.
You got the contact?
No, sorry. Look, this 8 is still under this radical bar. Now, can 8 be rewritten as what?
4, 2.
4 times 2. 8 is 4 times 2 and 4 is square root. So we're going to do 8 as the square root of 4 times 2. So now we have a plain 5. We have a 6 square root 2 minus the square root of 4 times 2. The square root of 4 is 2. And now we have 5 plus 6 square root 2 minus 2 square root 2.
That's it.
Well, now we have like radicals that can be combined. So now we can do, we have 6 of these minus 2 of these. 5 plus 4 square root 2. That's really setting you guys up for geometry. Have you guys heard of the Pythagorean theorem? A squared plus b squared equals c squared. When you're doing that, you're going to end up with square. Then I'll get the door. You're going to end up with square root. And so you did Pythagorean theorem before, but it was all integers. In geometry, it'll be radicals. All right, so now I'd like for you guys to find your handout from Thursday, and one person from your group put it in the basket. Sorry, I forgot about number 5. I'll get the door.
You're cheating?
My bad. 10. Does it divide by 4? Does it divide by 16? 30 doesn't divide by any of those. So, when it comes to multiplication, you can multiply radicands. So we're going to go ahead and make this 300. 10 times 30 is 300. You can smush it together, make it 300. Now that it's 300, 300 divides by 100. This can be written as 100 times 3. And so we can separate that. The square root of 100 is 10. And this is 10 square root 3. Actually, like maybe a little quiz left, and then we're gonna start getting ready for the exam. Yeah. All right, guys, we're gonna do some notes now. Write in your bell work. Write in your bell work.
Oh.
All right, the whole purpose of doing that is so that we can solve equations by using square roots. So go ahead and title it Notes, Chapter 9.3. Tell me what is that? Like, you don't have one done, right? Yeah. Okay.
Yes.
What is X? I get it.
Yes, I'll get mine. No, it
What is X? So, I just put, anyway, you guys know we're still talking about parabolas. We're still talking about quadratics. We're still talking about factoring. And here we're talking about solving when X is squared. So when you look at this, you can just use logic to say what X is. If something squared equals 9, then what is that something? 3. Does everybody agree that if we put a 3 in here, that 3 squared is 9? Right. Is there anything else squared that makes 9? There is.
Oh, that's 6.
No, that's 8. Good job. Good job thinking of that. What else times itself would make 9?
1.
No, 1 times 1 is 1.
9.
3. 3 times 3 is 9. What else times itself is 9?
9.
No, 9 times 9 is 81. 0 times 0 is 0. 1 times 1 is 1.
What times what makes 1 times 9?
No, but we need to, it has to be squared.
Oh,
Yeah.
no.
So, you got an answer. You got an answer. You know, it's not a test. We're learning. So, in this situation, X could be 3. 3 times 3 is 9. But also, we got negative 3 times negative 3 is also a positive 9. So 2 answers check out here. This is how we're going to show the work for x squared equals 9. And this was our first example, so it's probably going to get more complicated, right? What we're going to do is we're going to put a square root bar on the left and right side of the equation. And a square root bar and a 2 of an exponent are perfect opposites. They cancel each other out. It's like adding 2 and subtracting 2 at the same time. It's just like perfect inverses. So when you square root x squared, it cancels the exponent and the power of 2, and you get x equals, and we're going to stack our plus and minus sign and say x is positive and negative 3. You see that? That's how it looks in Big Ideas Math too. I think sometimes they separate it, but sometimes you'll see the plus sign written over the minus sign, and that just means x is both 3 and negative 3. So that's 2 answers. Yes, it's pretty much inverse operations. You know what else it is? It's also a parabola. So you guys know your parabolas are symmetrical.
The x-intercept would be 3 and negative.
X-intercepts would be 3 and negative 3. So don't forget your visual here. This is the parabola, and here's your 2 answers.
The vertex would be 12.
This is x squared minus 9. Don't want to confuse you, but yeah, we're looking at 2 zeros here, at 3 and negative 3. All right. Yes. Okay. All right, we have two more examples, but I want to give you some steps to fall back on. I feel like some of my notes got erased. So this is solve by square rooting.
That's a lot of work.
You don't have to write it all. Okay, isolate x squared by moving any terms to the other side of the equation. So step one is to isolate. Your most basic equations will already be isolated, like the one we just saw. You usually are going to have to cancel out and add and subtract before you multiply and divide. That's a tip for you. Then you square root both sides. Remember, the square root of x squared is x. Remember to use the plus and minus sign. Two answers, positive and negative. And then simplify the radical when possible. These are the 4 steps you're going to take in solving your equations today. Sure, if you're going to read them. If they'll be useful to you, write them down. No.
Oh, man. It'll be useful if I read one.
Is it worth it? Not bad, right, Nathan? Not bad this topic. Yeah. Yeah. Just a couple more. I tend to like tend to teach you all the way through, you know. So like we're gonna, but I will start reviewing soon. And we'll do 2 examples, and then we'll look at what the book has to say. Yeah.
Yeah.
And I got a pencil sharpener there. Yeah, I got one. I think I've said.
Oh, wait.
Wait, why are you reading in the right order for the on the road? That's what the R0. I'll tell you this, David, since you got first equation right.
Yeah.
Zero.
Wait, whoa.
This is what we just did. We got 3 and -3. So before I put it in decimals, I would move this 9.
Why do you need this?
And then this is what you put into decimals to get the 3 and the -3x. No, that one you have to do like all by yourself with no tools.
Okay.
All right, let's do these 2 examples. Are you on step 3 yet? No. Okay, go on.
You think it like 9?
I know.
Why? 25%. I don't think
Problem. I'm gonna in like 2 more seconds scroll up and there'll be 2 examples, and if you can just check in on those 2 examples, you'll be fine. I think you're the only one. So thanks for being the spokesperson.
They're trying to figure out what to make it work.
Wait, what?
Alright, 2 problems. Oh, there's 3. Oh, yeah, there's 3. Okay. Here's the 3 problems we're gonna do. It's weird how they get bigger. Oh, what happened? This is called solve by square rooting, James. And honestly, the lesson we did last week on square rooting was really so that you could do this here. It was Wednesday. Well, what we just did in Bellwork. The point of being able to know how to rewrite is so that you can solve these equations. Remember when x squared, we're talking about parabolas. Okay, step 1 is to isolate x squared. So, what does that mean?
Get x by itself.
Yes, we need to get x squared by itself.
So this equation, what should we do for subtraction or the square?
The subtraction. So you will typically do addition and subtraction first. You hear that? So what I'm going to do first is add this 27, add this 27. And my new equation will be 3x squared equals 27. I'm trying to isolate x squared, get x squared alone. Now the only thing left with the x squared is the 3. What should we do with the 3? Divide by 3. Colin, are you with me? That was step 1. Isolate x squared. So we had to add 27, divide by 3. Now this looks exactly what I just showed you already. So now we're going to square root both sides. Keeping in mind that a radical bar and a power of 2 are perfect opposites. They will cancel each other out. And x is now plus and minus the square root of 9. And the square root of 9 is 3. So that's an example of a long equation that ends up with those same answers, positive and negative 3. But you already did this before when there wasn't a power of 2, add 27 divided by 3, you know? So just do that part and then square root. The reason it's plus or minus is because when you look at x squared equals 9, like 3 times 3 is 9, and also negative 3 times negative 3 is 9. So it's both positive and negative 3. And then, honestly, we just want to get you comfortable with the plus and minus stacked, but you could just write it 3, -3 separate like this, and that's fine too. You don't have to use that symbol. You need to recognize it. Yeah.
What 14 is actually like 0 or 1?
Just 0.
Just 0.
Yeah. Alright, number 3. That break. The pencil break. If it doesn't start again, you can use one of these. Okay, sharp right now. Alright, let's head to number 3. Did it work? Okay, you can just get one of those just in case. Alright, so I'll put the line in. This time I have to subtract 12. I get x squared equals -12. Then, sorry, -2. 10 minus 12 is -2. And then I stop. Numbers squared are never negative. So this will be a trick question that you stumble across. If you get x squared and it comes out negative, you stop and you say no real solution. So number 2 had 2 real solutions, both positive and -3. Number 3 has no real solution. And then number 4, I think, only has 1 answer. So there's 3 possibilities. No answer at all, 1 answer, or 2 answers. All right, number 4. Why is there no answer on number 4? Yeah, when I add 10, I get 0. You can square root 0. I should have put it in the list. Yeah, the square root of 0 is 0. So I'm gonna alter my list. I got the 1. I should have put 0. 0 squared is 0. Square root of 0 is 0. So this one you don't need the plus or minus for. It's only 1 answer and it's 0. So in this situation, it's when the parabola doesn't go through twice, it just touches right in the center, or even touches somewhere along the center. There's only 1 solution. So
there's no x intercept at all.
There isn't at 0. There's only 1 right at 0. It touches right in the origin. Okay. All right, you guys are online. Big Ideas Math. You have 14 of these.
14. It's not big idea.
It's not? Okay, I'll make it available to you right now. So log in, go to Big Ideas Math.